Dear students, welcome back. And in this class, I'm going to cover the following topics: optical fiber communication, advantage of the optical fiber communication system, and the application of the optical fiber. So let us proceed. Now this is the block diagram for optical fiber communication. So as we can see over here, this part is called the transmitter part. This is your transmitter. So it will have, for the block diagram, will have the three parts. First part is called the transmitter. Second part is called the optical fiber, and third part is called the receiver. So optical fiber communication has been divided into the three parts. The first part we are calling as a transmitter. Transmitter is your first part. Second part we are calling as the optical fiber, right? That is the communication channel. And the third part we are calling as the receiver. So we have got a three part in this block diagram. Now all these three parts, one by one, we are going to understand and how it is going to help us in sending the signal from one point to other point. This is what we are going to look into it. So let us begin with this one by one. Firstly, we are saying the optical fiber communication system consists of the transmitter. So the first part is transmitter. Then information channel, that is the second part is information channel, and the third part is the receiver. So we have the three part for the optical fiber communication. Transmitter convert any electrical signal into the optical signal. So what we have, this we'll see in the detail. So whatever the electrical signal is being given from here, so that electrical signal is finally getting converted into the optical signal, and the optical signal will travel through the optical fiber, and then finally that optical signal is getting converted into the electrical signal, and then finally we are going to send to the destination in a certain way that we'll look into. Alright, information channel carries the signal from the transmitter to receiver. So here information channel is nothing, it's your optical fiber. In this case, information channel is your optical fiber. In case of the copper wire, we are taking the coaxial copper wires. So we can have the different information channel. Here the information channel is optical fiber. Alright, the receiver converts optical signal to in the electrical form. That is, the optical signal has been converted into the electrical signals. Alright, so these are the three parts of your communication. So what are these three parts? We have the transmitters, then we have the information channel, and the third part is receiver. Let us see all these part and sub part of the entire communication system. Now again, let us see this again, the same block diagram has been shown to you over here. So first we are coming to the input signal. So what is the input signal? Let us suppose here I am speaking or my video is going on in this, and let us suppose my video is required to be sent through the optical fiber. So then what is required to be done? My voice is to be converted into the electrical signal, and that will call as the input signal. So whatever the information we have to send it, that information is to be converted into the electrical signal, and that we are calling as the electrical message converted into the electrical signal. Right, so my voice will be converted into the electrical form, and that is going to be taken as the input. So this is your first part. Second part, as you can see here, we have the coder or converter. What we have? We have the coder or converter. So this convert the electrical signal into the proper format. What can be the formats? Now the format can be, here we can have the either the analog signal, or we can have the digital signal. So this converter, the electrical signal which is coming to the coder or converter, so coder or converter is going to convert this into the proper format, that is either into the analog or in the digital. What is the difference between the analog and digital? Analog is a continuous signal, but in case of the digital, you have the on and off state of that. Let me give you one example. Let us suppose if you want to measure the temperature with help of the thermometer, you have the two type of the thermometer. One thermometer where you can see the temperature will be slowly rising. If you have the fever, then temperature will be slowly rising, and that is called as the continuous. In case of the digital, again, if you have the digital thermometer, you are putting for some time, and finally the temperature will come in the digital form. So that is called digital. So you are getting one particular value. It is not going to vary continuously. Alright, so that is the work of the converter. So converter is converting into the proper format of the electrical signal. All right, either it will be the digital form or it will be in the analog form. Then we are coming to the next one, and next one is your light source. Now, as we know, the electrical signal is to be fed on the lights and light is going to carry the electrical signal through the optical fiber to the destination. So we require to have a light source which is going on which we are going to feed this analog or digital signal. So what type of the light we are going to use? We are going to use either the LED, this is what you say, light emitting diodes, or laser diodes. Laser diodes, these are the source which is being used on which we are going to feed the signal, right? So this is the next part is your light source. Now let us go to the next. So after the light source, what you are getting here, the next that you are getting there is the source to fiber interface. Now what is happening is, now once we have fed on the optical fiber, on the light, the electrical signal has been fed on the light wave. Now light wave will carry your electrical signal. So between this light wave and the optical fiber, we require a coupler. What we require? A coupler which is going to be fitted in such a way that this is going to carry your light wave inside this. So this is that is called the fiber junction. That fiber source to the fiber interface is going to be attached with the coupler. All right. It is a mechanical interface between the light emitted by the source into the optical fiber, which is which is similar to the lenses, right? So that is called coupler. So here we can use, this is your input coupler. So through the input coupler, what you are going to do, the light, whatever the light is there, light will be injected into the optical fiber. Now let's see the next one. Then you have the information channel. So what is the information channel here? Our information channel is nothing, it's an optical fiber. So now light is coming through this information channel, that is the optical fiber, by the total internal reflection. All right. Now this information channel can be of the two types. One can be the guided, another can be unguided. For example, let us suppose I am speaking in a open air theater. If you are, then also you are able to listen the sound, right? So that is the example of the unguided information channel. So atmosphere in that case become unguided information channel. Why it is information channel? Because through this the information you can communicate, right? And another can be the guided, right? So here the optical fiber is a guided channel. Similarly, you have the copper wire through which we are using to sending the signals will also under the category of your guided channel, right? So what we are saying, coaxial cables, two wire lines and rectangular waveguides are example of the guided channels. In here the guided channels is your optical fiber. In optical fiber communication, the information channel is the fiber optic cable, right? Okay, so now let's proceed further. Now after that, we are coming to the fiber to light interface. Now what is happening? The light has come over here. Up to here the light has come, and now it has come to the destination. Now here again we are going to put one coupler. That coupler we will call as your output coupler, and through the coupler the light will enter into your receiver. To receive the light, what we require again? Here we require a coupler, and that will call is as your output coupler. So through the couplers, light is now coming to the receiver. So it is the first part, that is here the light is getting detected, right? So now let's proceed further. Now next is your light detector. Now what is coming through the optical fiber? Through this optical fiber, that is this information channel, light is coming, and on the light you have the electrical signal. So here now the light will be detected. So here detector is going to detect the light, and it is going to remove all the noise, all those things that it is containing. So all those things are going to be removed. How we are going to detect this? We are going to detect with this either the PIN diode or avalanche photodiode, that is also called APD. So that converts the optical signal to the electrical signal. So what we are going to do here, In this case, in the case of the light detector, the optical waves or the optical what we can say, the waves is getting converted into the electrical signal. That is, optical signal is getting converted into the electrical signal. So that is the work of detector. So this is your light detector, right? So now let us move further. Then we have the amplifier. Now amplify the signals and filter the undesired frequency. If any undesired frequencies are there, that is going to be filtered out. So naturally, if it is going to travel to the thousands of the kilometers, so its intensity will also decrease. So that intensity is also being increased by using the amplifier. So here you have got the amplifier. Using this, your intensity can also be increased. So that is your amplifier or decoder, right? Now this is also going to convert not only into the electrical signal, then it will also convert, if it is your analog signal, it will give you the analog, or if it is your digital signal, it will convert into your digital form. Similarly, finally we have the message output. So the output message will be in the two forms. Either it can be your sound in the form of the sound, or it can be in terms of the video. So electrical signal can be converted into the sound wave or the visual image by using CRO. So finally we have after this, finally we have the CRO, and with help of the CRO, now it is finally going to the final destination, that is the target. So finally we are sending the signal to the target. Alright, so this is about your optical fiber communication. Now what are the advantages of the optical fiber communications? So now let us see, it carries very large amount of the information in either digital or analog form due to large bandwidth, because the optical wave have got a very large wavelength compared to your microwave. So naturally it is able to carry lot of information, that is huge data can be transmitted from one place to another place. This is the second one, is a very important property, that the core of the optical fiber are dielectric in nature. They are dielectric in nature, so it does not produces or receive any electromagnetic and RF frequencies or interferences. It is not going to produce any electromagnetic or RF frequencies, and if it is not going to produce any such type of the interferences, your disturbance will be minimal. The fiber are much easier to transport because of their compactness and lightweight. Naturally it is being made with the silica, its diameter is very small, so naturally it is going to be lightweight, so it can be easily transported from one place to other place. It is easily compatible with the electronic system, so you can use in the electronic system, like in your TV or the computer, CRO, anywhere. If you have to communicate the signal, immediately you can use in any of the electronic system. Alright, so it is highly compatible in any electronic system. It can be operated with in the high temperature range. So even in the high temperature range, you will not have any deformations, right, in the communication, that the signal is not getting deformed. It does not pick up any conducted noise. So if any noise is coming, right, in between some noise has been produced, so those noise it is not going to pick up. Whatever the signal has been sent, only that signal is going to be transported. In between, if any noise is coming, so it is not going to pick up any noise, and so more or less during the transmissions your signal is safe, not affected by the corrosion and the moisture. So naturally it is corrosion free because it's made of the silica or the glass, so it is non-corrosive, and it will not contain any moisture. It does not get affected by the nuclear radiations. Again, this is an important parameter. The last one, we say no sparks are generated because the signal is optical signal. Since we are just sending the optical signal, so there is no case of any spark like your microwave, and therefore you can use safely. There is no case of getting a burn or the fire, all those things. So this is your advantage of the optical fiber communication system. Finally, we are coming to the some of the applications. You have the infinite applications, but just the sake of your syllabus, I have taken some of your applications. Now, undersea cable system are laid in international telecommunication network, right? So even for the international telecommunication network, or what you many a time you call the hotline, is being established between the two countries through the optical fiber network. And you can easily do it even through the sea route, because you know you have the sea which is going to protect your fiber against any weather condition. In telecommunication network, like the telephones, teleconferencing, and cable TV, etc., we use, and all of you must be seeing at your home as well. In the digital transmission telecommunication network, so this is another application. In local area network system, even your college is on the LAN system. Optical sensor system in military mobile applications like the ships, aircraft, etc. we can use this. So this is your some of the applications of your optical fiber. In this way, we have finished the optical fiber, and we have not only finished the optical fiber, we have finished the entire module 3. Right now, very soon I am going to start the module 4. Thank you very much.